Hello, welcome to my presentation on predicting pet adoption likelihood in Ireland using machine learning. This project is aimed at addressing a critical challenge faced by animal rescue centers to understand and improve pet adoption rates. By leveraging synthetic data and machine learning models, I explored how factors such as age, health condition, breed, and urban area influence adoption outcomes. The primary goal of this project was to uncover insights into pet adoption trends in Ireland and predict the likelihood of adoption based on several key features. Initially, I intended to work with data sets from both Ireland and the UK. However, access to the UK data center was denied, so I decided to focus only on Ireland. This decision allowed me to dive deeper into the Irish dataset, although Ireland alone posed challenges due to the lack of data available on pet adoptions. To address this, I created a synthetic dataset of 5,000 records based on trends reported by organizations such as Petmania and Dogs Trust. The dataset includes features like pet type, breed, age, months, size, health conditions, and etc. Each feature was carefully designed to reflect real-world adoption scenarios. For example, health condition and age months were randomly weighted to align with actual trends, such as older pets and those with special needs being less likely to be adopted. Pre-processing involved encoding category variables, standardizing numerical features, and splitting the data into training and testing sets. These steps ensured that the models could effectively learn and make accurate predictions. I implemented four machine learning models: decision tree, random forest, gradient boosting, and logistic regression. Each model was chosen for its specific strengths. For instance, random forest provided insights into feature importance, while gradient boosting excelled at handling imbalanced data. Decision tree offered simplicity and interpretability, and logistic regression served as a baseline for comparison. To evaluate these models, I used metrics like accuracy, precision, recall, and F1 score, which provided a clear picture of how well the models performed. Accuracy showed how often the predictions were correct overall. Precision focused on how many of the predicted adoptions were actually accurate, while recall measured how many adoptable pets the model correctly identified. The F1 score combined precision and recall into a single measure to balance these two aspects. I also fine-tuned the models like adjusting tree depths for the decision tree and learning rates for gradient boosting and improve their performance in better suited datasets' unique characteristics. The results revealed that the health condition was the most influential feature, followed by age months. Adoption rates for older pets and those with special needs were significantly lower and visualized through graphs like these ones. Additionally, adoption likelihood by urban area highlighted the need for more localized data. For example, counties like Kildare were grouped into other, limiting insights into restricted breeds. Overall, the models achieved strong performance with decision tree and logistic regression achieving the highest accuracy at 90%. While the project successfully identified key adoption factors, it also had limitations. The use of synthetic data through realistic lacked validation against real-world data. Geographic bias was another limitation, as most data focused on urban areas. For future work, I would love to collect real pet adoption data from shelters across Ireland and explore additional features, such as owner's financial situation that could be a barrier as well. Incorporating natural language processing for analyzing pet descriptions could also enhance predictions. The findings have real-world implications. Shelters can tailor their campaigns to highlight the positive traits of older pets and those with special needs. Sharing success stories like the greyhound adopted after its racing career ended Such narratives can shift public perception, encouraging more adoptions. Strategic efforts such as health focused messaging and adjusting adoption fees for higher barrier pets can further enhance adoption rates. In conclusion, this project demonstrated how machine learning can address adoption challenges by predicting outcomes and uncovering trends. By focusing on factors like health, age, and geographic area, we can provide actionable insights from shelters to improve adoption rates. Thank you.